Hey there. So usually in mathematics, we are talking about equations, right? Equations are all over the place. But the equations aren't the only thing we look at in math, right? There are other kinds of ways of relating to quantities, right? So I might make a statement about the fact that I earn less than Susan, right? Less than is a relationship between my salary and Susan's salary, but it's not they're not equal, right? It's something else, right? So these are called inequalities, all right? And there's a whole mathematics for inequalities, just like there is for equations, all right? So that's what we're going to be talking about today, how to deal with inequalities. And in this video, I'm just going to be giving you an overview of just kind of the basics of how the inequality symbols and how basic inequalities work. And in a later video, we'll talk about solving inequalities, okay? So let's take a look at these inequalities, okay? So first of all, let's just remind ourselves about equality. You know this already, but let me just put it down here for completeness. If I write this symbol, you know what that means. That means is equal to. Is equal to. Okay? Now, what were these? When I said that my salary is less than Susan's, well, that's another one, right? Is less than. That's the less than sign, okay? And of course, we also can go the other way. I am taller than my neighbor's dog, right? So my height is more than my dog's height. So this is more than or is greater than. That's the greater than symbol. And there's some slightly different ones to these. So sometimes we make statements like, I want to earn at least this much, or I want to have no more than this many complaints in a week, right? So at least and no more than. These are slightly different than these symbols that we've written down already. These, when I say no more than, I'm allowing the amount to be equal to. Just as long as it doesn't go over, I'm fine. Right? If I don't want any more than 5 complaints are okay. I'm okay with 5 complaints, but I don't want any more than that, right? So no more than means less than, or it could be equal to. And so that's the other kind of inequality that we can talk about. So let me scoot over here. Oh, I'm moving the whole screen. Sorry. So that's another kind of inequality. So we have this symbol, less than or equal to. So this means is less than or equal to. And so if I said, let me scoot that over a little bit more. So if I said no more than, same thing, right? So no more than is another way of saying this. And you'll see in the English language, there's lots of different ways to say these, right? It's like equals to. You can say is, or you can say equals to, or you can say the same as. There's lots of ways to say these. And the other one, if I want to have, if I want to earn at least this much, if I want to earn at least $15 an hour, I'm okay with $15 an hour, but I also would not mind having more, right? So I'm allowing it to equal 15, right? So it's greater than or equal to. And so that's the other symbol we have. This is greater than or equal to. Okay, so these are our inequality symbols. We have equality, which is the one we're used to, equal sign, and then we have these inequality signs. Okay, so we're going to be talking about inequalities, which are analogous things to equations, but using these symbols instead of an equal sign. Okay, so let's go down and just look at some examples. Okay, so here we go. Let's take a number line here. We'll draw a picture on this number line after we write this down. So I'm going to start with an inequality, and my inequality is going to be x is greater than 3. I want to talk about what does this mean graphically, right? So, well, what does it mean just conceptually first? To be greater than 3 means we are more than 3. So we know what numbers are greater than 3, like 4 and 5 and 6, but also 3.5, 3.1, 3.0001. These are all greater than 3. So as long as we're more than 3, then we're fine. So let's try to plot this on the number line, all right? So 3 is right here. To be more than 3 means we are to this side of the 3. So there, I've graphed this inequality. I indicated all numbers that are to the right of 3. And so we see that the greater than sign also can be interpreted as to the right of on the number line. Okay? So what about greater than or equal to? How would that one work? Right? So if I said x was greater than or equal to 3, how would I draw that? Well, okay, so here we are at 3. Greater than is this. Okay, we already did that, but it's or equal to, so it could also be equal to 3. So we have to allow the possibility that we are exactly at 3. So what I do is I fill this in, just like that. So that's indicating that we could also be at 3. By leaving the dot open, I'm indicating that no, we're not allowed to be at 3. We just have to be only to the right. But this is allowing all numbers greater than 3 or equal to. Okay, let's look at some other ones here. Let's look at x is less than or equal to, keep doing that. I got to get used to this new system I have here. Okay, x is less than or equal to -1. Okay, so there's -1. What does less than mean? Well, it means to the left, right? So what I'm going to do is shade off to the left. Now it says or equal to, so it could also be equal to -1, so that means I'm going to fill this in. And that's how I would graph that inequality. Okay? And let's talk about one more. Let's talk about, before we go on, we'll talk about x is less than 4. What about less than 4? Well, here's 4. To be less than 4 means we're to the left, right? So I'm going to shade these to the left. And I'm not going to shade in the 4 because we're strictly less than 4. We can't possibly be equal to 4. So these are the differences. I hope you can tell the difference between these inequalities here. Right? There's 4 types. Okay? The or equal to determines whether we shade it in or not. Okay, but I'm going to point out a couple other possibilities. Okay, so let's go down a little bit and let's look at an inequality. I'm actually going to draw the picture first, and then we'll try to see what inequality it might correspond to. All right, so what I'm going to do is maybe go from here up to here, and let's shade the 2 in. All right, and I'm going to shade in all these numbers. So I'm talking about all the numbers in that range. Now, how would I write that as an inequality? Well, I see I've got numbers greater than -3, and I see I've got numbers less than or equal to -2. So anything in that range is both greater than -3 and less than +2. So that is one way to write this down. All right, so you could say x is greater than -3 and x is less than or equal to 2. That's one way to write it. However, there's a special thing we can do here to write it a little bit more succinctly, more compact. And that is called a compound inequality. We can put these together. So if x is greater than -3, that means that -3 is less than x. Those are the same statement. Think about it. X is greater than -3 is the same as saying -3 is less than x. Same statement. But we also know that x is less than or equal to 2. So I can just put that right here. And this is called a compound inequality. And so this is another way of writing it. Okay. So let's look at one more. Well, we'll look at a picture where this time I'm going to shade differently here. So let's do, let's have the numbers that are less than -1 and the numbers that, well, let's fill that one in. Let's do it on this side this time. And then we'll do the numbers that are greater than 4. So what does it mean for x to be in this shaded region? Well, it either needs to be less than or equal to -1, or it needs to be greater than 4. Can it be both? No, it can't. You can't be both less than -1 and also be greater than 4. So that's why I'm using an or here as opposed to an and. Last time, you could be both one inequality and also the other, so we put an and. Here, you have to be one or the other. You can't be both, so I write an or. And notice the difference in the pictures. In this picture, we have it going apart, whereas in this picture, we have just one interval. The two inequalities are kind of overlapping together, right? So, question is there a fancier way to write this one? And the answer is no, right? There's no fancier way to write this. So this is the final answer. What you do not want to do is something like this. Say, okay, well, -1 is greater than or equal to x, because that's the same thing as saying x is less than or equal to -1. So I agree, those are the same. Nothing wrong yet. And then writing this. Does that make sense? Well, it might look okay at first glance, but when you look at it more closely, look, if -1 is greater than or equal to x, and x is greater than 4, that would mean that -1 is greater than 4. But that's not true. -1 is to the left of 4 on the number line, so that doesn't work. So we have to be very careful here, okay? If the intervals are not, if they're going in different directions, we have to write our inequality with an or. If they're going in if they're making a single interval here, then we can get away with writing a single compound inequality. Okay, so these are the basic types of inequalities. Okay, we have greater than or equal to, less than or equal to, less than, and then we have our, I keep dragging the wrong screen, and then we have our two compound inequalities, right, where we have to write two inequalities side by side, but only one of them can we string the inequalities together, and that only corresponds to the situation where we have an and. Okay, so that's it for this video. We'll talk more about inequalities and solving them in a future video, so I'll see you then.